Welcome to Academic Avengers and to episode 2 of our podcast series From Earth to the Stars. In this episode, we're diving into one of nature's most magical light shows. In the far northern skies, a magical light show dances silently across the darkness. These glowing waves, often green or purple, stretch across the stars like curtains fluttering in the wind. People call them the Northern Lights or Aurora Borealis. In the Southern Hemisphere, a similar light show happens called Aurora Australis, the Southern Lights. These lights are not just beautiful. They're the result of powerful forces from deep space and our own planet working together. It all begins with the sun. The sun is not just a source of light and warmth. It's a giant ball of gas, constantly producing energy through a process called nuclear fusion. This energy sometimes bursts out in huge waves, throwing charged particles into space. These waves, called solar flares or coronal mass ejections, release billions of tiny particles, mostly electrons and protons. This constant flow of charged particles from the sun is known as the solar wind. As the solar wind travels through space, it eventually reaches Earth. But Earth is not defenseless. Our planet is surrounded by an invisible magnetic shield called the magnetosphere. This shield is created by the movement of molten iron deep inside the Earth. It protects us by deflecting most of the solar wind. However, near the north and south poles, the magnetic field lines bend inward, creating openings where some solar particles can enter the atmosphere. When these charged particles enter the upper atmosphere, usually at heights between 80 and 500 kilometers above Earth, they collide with atoms of gases like oxygen and nitrogen. These collisions give energy to the atoms, exciting them. When the atoms calm down and return to their normal state, they release this energy as light. That light is what we see as the aurora. The color of the light depends on the type of gas and how high the collision happens. Green is the most common color, caused by oxygen atoms about 100 to 300 kilometers above Earth. Red is also from oxygen, but occurs higher in the atmosphere, where there's more time for the light to be released. Blue and purple colors usually come from nitrogen molecules. Auroras only happen near the poles because of the shape of the Earth's magnetic field. It channels the solar particles toward the magnetic poles, like a funnel. That's why you see them best in places like Norway, Canada, Alaska, and Antarctica during strong solar storms. However, the auroras can stretch farther from the poles and be seen in more southern locations. These solar storms, also called geomagnetic storms, can be powerful. They not only produce beautiful auroras, but can also interfere with satellites, GPS systems, and even power grids on Earth. In 1989, a solar storm caused a blackout that affected 6 million people in Canada. That's why scientists carefully watch the sun and its activity. Space agencies like NASA use satellites to monitor solar flares and help predict when auroras might happen. Even though auroras look like they belong in a fantasy world, they are entirely real and deeply connected to physics. They show us how energy moves, how magnetic fields protect our planet, and how atoms react to collisions. In fact, some people have even reported hearing soft crackling or popping sounds during intense auroras. Scientists are still exploring how this could happen. The Southern Lights, or Aurora Australis, follow the same rules. They're just as beautiful, but harder to see because fewer people live near the South Pole. Still, they are a reminder that the entire Earth is part of a bigger system, constantly affected by the sun and space weather. Seeing an aurora is more than just a nice view. It's a connection to the universe. It reminds us that Earth is not alone. We are part of a solar system filled with motion, energy, and invisible forces. The northern lights may look soft and gentle, but they're the result of enormous cosmic power. They are nature's own neon lights, glowing high above, thanks to collisions between atoms and space particles. Before you go, don't forget to subscribe to Academic Avengers and share your thoughts in the comments below.